In our quest to explore the universe, finding liquid water is key to discovering new life forms. Water is at the heart of space exploration, whether quenching an astronaut's thirst, launching rockets into space, or monitoring the water cycle and health of our own planet.
To solve humankind's greatest challenges and answer our most profound questions, we are driven to look for water in space. Hey everyone, I'm Tyler. And this is my younger brother, Alex.
And together, we're the Water Brothers. We're going to take you on an adventure around the world to explore the state of our blue planet, a planet defined by water and its ability to sustain life.
So join us on our journey as we explore the world, looking at the most important water stories of our time.
And together, we will learn how to better protect our most precious resource. Earth, the blue planet. Over 70% of its surface is covered by water, and for now, the only place in the universe known to harbor life.
Exciting new missions into deep space could soon determine if there is life beyond Earth, and these journeys are forever tied to a search for water.
The search for water is not only important if we imagine we're going to ever colonize a planet or a moon. It's also important in the search for life as we know it. Life as we know it requires liquid water for its survival. So if we want to find life and boost the chances of it being something like us, we're going to make a list. All right, that planet's just too hot, or this one's too cold, and this one looks just right. So we're going to look for Goldilocks places in the solar system. So yes, now one of NASA's mantra is follow the water.
The universe is filled with water. In distant galaxies, clouds of water have been discovered that are trillions of times the size of Earth's oceans.
Comets and asteroids can also contain vast quantities of frozen water, and asteroids are one possible source of the water that arrived here on Earth billions of years ago.
Water is surprisingly common in the universe. It's liquid water that's quite difficult to find. And within our own solar system, only one other planet besides Earth is believed to have ever contained water as a liquid.
Today, the surface of Mars is an inhospitable desert, but recent satellite and rover missions have revealed telltale signs that the entire planet's surface has been shaped by moving water.
There are river basins and river deltas and floodplains resembling some of the topographic features you find in the Midwest when it rains too much, too quickly. So all of this evidence tells us that water, or some common liquid, was flowing freely and rapidly over the Martian surface. No one doubts that Mars didn't once have liquid water. One of the big questions is, where is it now?
The more we learned about Mars, the more we realized that there's a significant amount of water in Mars, inside Mars right now. It's also in the polar caps, buried by the carbon dioxide snow. We see it in aquifers. It leaks out, goes down the sides of craters during certain seasons. We see that in the past, Mars had a significant amount of water flowing on its surface, maybe oceans. Mars looked more like Earth today than anything else.
One thing we learned in the past several decades is that the moons of planets are, in some cases, more interesting than the planets themselves.
Several moons orbiting Jupiter and Saturn have been known for decades to contain vast quantities of solid ice. But recent discoveries suggest that the water on these moons does not always remain frozen.
One of Jupiter's moons, Europa, is well outside of our Goldilocks zone from the sun, so you don't expect it to have liquid water, were it not for the massaging effect of Jupiter's gravity competing with the gravity of other moons. As Europa moves around in its orbit, Jupiter distorts it a little bit, and then the other moons distort it, and so there it is, constantly being distorted. In much the same way a racquetball is distorted every time you hit it. Have you felt a racquetball after you hit it a few times? It's warm. You've been pumping energy into it by hitting it, and it's been rebounding. And every time you do this, you raise its temperature just a little bit. That has happened on Europa. The ice surface is liquid beneath it by every bit of topographic evidence we can summon. And it's likely been liquid for billions of years. So, as I've said before, I want to go ice fishing on Europa.
Europa's ocean is thought to be twice the volume of all the surface water here on Earth. And together with the heat created from the tidal forces of Jupiter, two of the most essential ingredients for life are present.
We also believe at the bottom of the ocean are potentially hydrothermal vents, places where heat is constantly generated through these tidal forces of Jupiter and continually melting the water. And that makes it an extreme environment where potentially it could be very hot. And when we go to our hydrothermal vents here on the Earth, they're teeming with life. And it's because the nutrients and the energy necessary to keep this life alive, in addition to the water, is there in abundance. That may be happening at the bottom of Europa's ocean too.
If we wish to discover both liquid water and life beyond Earth, we will eventually need to send humans to distant worlds like Mars and Europa, journeys that will take months or even years to complete.
Keeping astronauts healthy and alive is a tremendous challenge. And aboard the International Space Station, teams of astronauts have been living in space since the year 2000, trying to overcome these very problems.
To get a sense of this important work being done, we sat down with Canadian astronaut Chris Hadfield, a veteran of 3 space flights and a former commander of the ISS, where he lived for nearly 5 months.
So Chris, you've inspired so many people by changing their perspectives of Earth, of what it's like to be in space. And just for my brother and I, you've been a big inspiration as just being an amazing ambassador for Canada, and also for your legendary mustache, which is why we've decided, spent the last few weeks growing ours to pay homage to you.
Congratulations on the mustaches. They're coming along very nicely.
Thank you.
And maybe to mix everything together, you might try watering them a little bit.
Is that your secret?
No, it just takes time.
One primary mission of the ISS is to develop life support systems that will be efficient and reliable enough to keep astronauts like Chris alive for long space journeys.
When people start to explore, at first they stay close to home. And when we were getting ready to sail the Atlantic, the sailors went up and down the coast thousands of times for many, many years before they sailed west and went across the Atlantic. What we're doing in space right now is the same thing. We're orbiting the world and learning how to figure out what you need. What food do you need? What do you make your ship out of? How do you make the toilet work? How do you recycle the water? How do you do all those things before we head further out into the universe?
Do you think that the provision of water to astronauts will be a challenge for future missions as we push deeper into space?
When I lived on the space shuttle and helped build the Russian space station here and the International Space Station, of course, we just brought a finite quantity of water, like going on a camping trip where you bring some jugs of water with you. So you know how much water you have left, you know how many days, no big deal. On a space station, you could do that, but all your ships coming up from Earth, they would just be full of water. And so you're very concerned about how much water is on board. And often it becomes our limiting resource. If we're trying to decide how many more days can we stay on station, it's maybe not oxygen supply, it's maybe not food. The limiting factor might be water, and it often is.
On average, it costs over $60,000 to send a liter of water into space. So anytime you can cut down on the amount of water you send up into space, it leads to huge savings. And that's what's brought us here to the Marshall Space Flight Center to learn how scientists here are turning urine into clean drinking water.
Since 1960, this center in Huntsville, Alabama, has been NASA's primary hub for developing rocket propulsion systems. Many Earth and space science activities continue to take place here, including the development of the water recovery system that recycles wastewater aboard the International Space Station.
On average, we need about 4,000 liters each year to support the crew that we have on the space station, just in the U.S. segment. That cost about $250 million to fly up that much water. So that's how much we're saving with this water recovery system.
So it saves a lot of money and it allows more astronauts to, I guess, maybe even stay longer up there.
Exactly. We basically were able to double the size of the crew and therefore do twice as much science.
And we're going to get to test out the urine processor today, right?
Absolutely. We need some samples. We need some urine so that we can go off and show you guys how this system operates.
Time to give a donation.
While the first few steps of the water recycling system must be conducted manually here on the ground, on the space station, the entire process is automated.
So we've just poured in the sample. It's mixed with a whole bunch of other chemicals, and it's going to go through this whole system. The whole process takes about 2.5 hours, and at the end of it, we're going to get a nice, clean drink of water.
This system can recycle about 93% of all the water it receives. The process starts by separating the water from urine through evaporation with a distillation machine that spins to recreate the effect of gravity. Once the water vapor from the urine is removed, it condenses on the outer wall of the distillation machine and is then combined with wastewater from the astronaut's breath, sweat, and washing needs. From there, the wastewater is sent through a multi-filtration bed and oxidation reactor before it is cooled and ready to drink.
So Lane, just a few hours ago, this was a bucket of pee. It had some of me, had some of Tyler, had some of you and some of your colleagues. And now, after showing us how it all works, there's only one way to find out if it's good to drink.
That's right. We're going to have to do the sample.
All right.
Cheers.
Cheers.
That tastes pretty good to me.
That's excellent.
Clean water.
Yes, it's good quality.
It's great, yeah.
The water quality of this produced on the station is much cleaner than any water that you drink in a tap water that is on the ground.
The compact technology used to build NASA's water recycling system is so reliable and efficient that components in the machine are now being used to build portable water filtration devices for remote areas of developing countries. While these portable devices do not recycle urine and are only used to treat unsafe drinking water, their compact size makes them an ideal option for small, rural communities.
We're learning on the space station, so, about all sorts of things, but we're learning about water recycling. The system we have now works amazingly well. It takes all that waste and out of that little spigot out of the wall spits really clean, pure, potable water. And we just need to improve the system, include as many things as possible, and then we'll be ready to go to the moon, go to an asteroid, and maybe even head across the Atlantic and go all the way to Mars.
Improving water recycling technology will be critical for taking astronauts deeper into space. But how do you build a rocket powerful enough to take people the entire 70 million kilometer trip to Mars? Well, that's exactly what scientists here at the Marshall Space Flight Center are also working on. And as we'll soon find out, if you want to build a big rocket, you need a lot of water.
The Space Launch System, or SLS, is the newest and most powerful rocket NASA has ever built. Propulsion engineer Jeremy Kenny took us on a tour of the site where a 5% scale model of the SLS was undergoing tests.
So this model here is actually being used to understand the sound generated from this powerful rocket system at liftoff. Through small scales and continuous firings, we're able to generate a sound field to emulate what's happening in the full-scale rocket at liftoff. That way, NASA engineers such as myself can understand the liftoff sound and to design ways to suppress the sound.
And what's brought us here is because we've heard that you use a lot of water in the testing process and then also in the eventual launch when that happens as well.
That's right. But the sound levels that we're getting from these rockets are high. They're easily up to 165 decibels on certain sections of the vehicle and surrounding structure. But those kind of sound levels, you got to mitigate it. You got to suppress it. So one readily available feature that NASA engineers have been leveraging for all their launch vehicles is water. Being able to use water easily lets NASA engineers figure out different ways to tailor how we want to inject water and create sound suppressing curtains, if you will, in order to keep the sound levels down.
So without water, the sounds generated from the rocket would just create a whole mess of problems, I guess.
It could be bad news. Liftoff sound levels from these powerful rockets can rattle components all over the place. If they break, you don't get to fly.
So we've come inside the control room for the rocket firing, and that's because the noise produced by the rocket when it fires is so loud you can go deaf if you're too close.
Go.
That's huge. All right.
Only by using high-speed cameras and specialized microphones is it possible for the engineers to study the best configuration for water dispersal.
Pretty cool to think that the testing being done here is going to help develop the space launch system, and in just a few years, the rocket being tested here is going to lead to a huge rocket that could launch astronauts on journeys to Mars and maybe even further.
When the first full-scale rocket is launched in 2018, millions of liters of salt water will pour onto the launch pad to absorb heat and the powerful sound waves. That plume you see during rocket launches is not smoke, but mostly water vapor that becomes a cloud and eventually falls as rain.
The SLS will help NASA fulfill one of its major objectives, to send astronauts to Mars and beyond. But there is another planet in the solar system that NASA is studying more intensely than any other place in the universe.
It wasn't really on anyone's agenda when NASA was manifest in the space race that its energy or monies would focus on Earth. But then when we got to the moon, and you look back, I see Earth afloat in the darkness of space, seen as nature intends it to be noticed, with oceans and land and clouds. No color-coded national boundaries, none of these human constructs that we use to divide and conquer real estate, nations. What? It's Earth, we're a planet. So I, among many, are convinced that we went to the moon to explore the moon, but really we discovered Earth for the first time.
Holding on to the outside of a spaceship, suddenly you really see the Earth for what it is. A discrete ball, one small place in the universe. And it gives you a really profound respect for the enormity and the power and the permanence and the age of the planet, but also for the rarity of it and the uniqueness of it and the preciousness of it and the blue color of it, the amount of water that's on it. And so it absolutely drives home the necessity to take care of this one, because this is ours and this is where we're all from, and you have to be a good steward of it because there's nobody else to take care of it but us.
From its inception, NASA discovered that one of the most fascinating places to explore from space was our home planet. Since its first weather satellite in 1960, NASA has continued its Earth Science Satellite program to monitor our ever-changing blue planet, culminating in the creation of the Earth Observing System in 1997.
Most people think of NASA as sending people to the International Space Station or missions to Mars or other planets. But we really have a very large fleet of satellites looking down on Earth.
And the fantastic thing about satellites to study the Earth is they orbit the Earth every 90 minutes. And so you see the Earth day after day and year after year. And you have these data now, in some cases, for 30 and 40 years to study the evolution of the water cycle, of temperatures on Earth, in the oceans, in the atmosphere, and it's just revolutionized Earth science.
Whether they are warning us of severe storms, finding holes in the ozone layer, or monitoring deforestation and bringing international attention to nations using unsustainable forestry practices, NASA satellites benefit humanity in many ways.
And some of the most fascinating data is being provided by satellites specifically designed to measure the water cycle. From groundwater depletion to changing rainfall patterns, ocean currents, sea level rise, the loss of glaciers, and sea ice cover at the poles.
With so much still to learn about how water moves around the planet, in 2014, NASA launched the Global Precipitation Measurement Mission, or GPM.
GPM is an international constellation of satellites, and it's anchored by this core satellite that was developed by NASA and the Japan Aerospace Exploration Agency. But what's really amazing about GPM is that it can combine information from all of these other satellites in different orbits to provide a global picture of rain and snow everywhere around the world every 3 hours.
If you think about getting rain rate estimates every 3 hours everywhere in the world, we can start to be able to predict floods, landslides. We can track hurricanes better. With this mission, we're able to see more of the globe, so we can see hurricanes as they go, like Hurricane Sandy. We can see when it hits into New York City, we can see how much rain is falling out of it. And all of this data is important for science and society.
Using GPM data, farmers will be able to know the precise timing and amount of incoming precipitation, to forecast crop yields and be warned of freshwater shortages that might affect irrigation and production. With the capacity to more accurately predict certain natural disasters, GPM satellites will help save countless lives and prevent billions of dollars in property damage and lost crops.
Only by looking at our planet from space with satellites can we effectively monitor our dynamic Earth and better prepare ourselves for catastrophic events and the onset of climate change.
But if there is anything the human journey into space has taught us about water, it is the fact that Earth, its liquid water, and life are rarities that must be cherished. The universe is home to billions of galaxies and trillions of stars and planets, and we might never invent technology capable of taking us the vast distances to other habitable worlds. So we have no choice but to care for the water we have, because there is only one Earth.
I flew in space 3 times over almost 20 years. So I actually got to see changes on the surface of the Earth in the time that I was in orbit, changes that you can see with your naked eye. One of them is the Aral Sea. The first time I launched, it was still the 4th biggest sea on Earth. And because of human water use policies, we dried that sea up. Fundamentally, the Aral Sea is gone, completely caused by poor decision-making of human water use. Something else I noticed, when you come across the Great Lakes, the boundary waters between Canada and the US, they look so huge. I grew up around those lakes. They look enormous. But when you look at them from orbit, and they're somewhere around 20% of all the currently drinkable water on Earth is right there in those Great Lakes. And when you actually look at them from space, they look like what they really are, which is the last drying up puddles of the remnants from the last ice age. That's what they really are. They're just puddles that last a few thousand years. And I think that really soaked into me, the fact that something that looks permanent in 2 dimensions, once you get up into 3rd dimension, you can truly see the transient nature from that perspective, but also you can see the deleterious effects that we can have on something that used to be a huge water resource. And so it makes me think every time I turn on a tap, it makes me think when I look at water resources, and it makes me think about climate change and how that's going to move the distribution of water around the world. Global awareness is the only way that you can make global decisions. And being able to see the world from orbit really helps with global awareness.
Water is the essence of life, from the bottom of the oceans to the edge of the universe. And it definitely expanded our perspectives to realize that so many important discoveries made about water have come as a result of space exploration and by studying the Earth from space.
Whether it's the search for water on other planets or even moons, it's so exciting to know that within our lifetimes, our understanding of life in the universe could change significantly.
And as our Earth continues to experience unpredictable changes to its water cycle and climate, it's more important than ever to use satellites and space technology to monitor the Earth from above.
The human journey into space is an endless source of inspiration. And only by pushing the limits of our understanding of space
can we fully appreciate the value of the most precious resource in the universe.
Join us and dive deeper into the episodes at thewaterbrothers.ca.